Hi, and welcome to day 4 of our environmental data science class. Today we're going to continue exploring some of the impacts of the Hayman fire and try to better understand what are controls on the current greenness or NDVI of this area. So we're going to first open our project, the Hayman Fire NDVI project. I already have that open here. And you might want to open your old script because we might be referring to some of the text we already wrote for last lesson. And after that, we're going to add some layers of data. So first we're exploring this Hayman NDVI.csv, so we were looking directly at greenness. And now we want to look at some things that are correlated with greenness, like moisture. And we also want to look at things that might cause changes in greenness, like snow. So I went to Climate Engine and I downloaded, for the exact same polygons, I downloaded 2 additional remote sensing metrics. One is called NDMI, so the Normalized Difference Moisture Index, which is a measure of how much water is near the surface, either in the soil or in vegetation. And I also downloaded another data set called the Normalized Difference Snow Index, which is a measure of how much snow cover there is in a landscape. So if we go into our data folder, we have these additional data sets called Hayman NDMI and Hayman NDSI. And what we want to do is sort of look at those with the NDVI. And for this, I'm going to create a new script. I'm going to save it. I'll call it variation in NDVI. Okay, and we're going to need the same packages, so I'll just copy those over from the previous workflow. Okay, and now we have those in, and here we're going to start doing things a little bit different. So we have 3 files we want to read in. We could write this kind of script 3 different times, but we can do it in a slightly more efficient way. So I'm just going to write this little, I'm going to save this object called files, and I'm going to do that by saying list files that are in the folder called data. And when I do that, I get an object that contains the names of the 3 different data sets that we have in here. The problem here is when I list these file names, it's not the full names, so R wouldn't know that this is in the data folder. So in order to make it know that, I just add this full.names equals true. And now if I look at the file set again, it's going to actually include that these are all in the data folder, if you see the difference here in the bottom left. So I'll comment the files out so you don't run it, but if you wanted to look at it, you can just take out that comment. So here we're just going to say reading in files. And then now for each file, we want to read it in as a raw CSV. So we can go ahead and do that, and we can sort of look at the order. So we know the first one is NDMI. So we'll do NDMI, and we'll do read_CSV, and we'll do files, and we'll read the first one. So these square brackets just grab the very first component of that vector, which is files. And so if I just do up here, if I do files 1, you'll see that it's Hayman NDMI. And indeed, that's what we've called it, so that's good. So we're going to go ahead and read that in. And then we'll do NDSI next. Same idea, but now instead of doing files 1, we're going to do files 2. And then NDVI will be read CSV files 3. And when we read those in, we're getting the same column error from prior, but we're not worried about it too much yet. NDSI, that works, and NDVI works also. So I'll add a comment here, read in individual data files. Here we can see that we still have those really long column names, but we probably don't want to rename them for each one. So what we can do, and it's actually useful because in the column names it does tell us if it's NDMI. Some people call it NDWI, they're the same thing. NDSI so that's properly labeled and in DVI. So it does have some information in there that we might want to keep. So here we're going to use our first new function of the day. We're going to use a function called join, because what we have now is 3 separate data sets, and we can use the function view to look at one of them. And when we look at, this is now the NDMI data set, we have the date time column, this really long column name, and as with last time, this is the burned plot and this is the unburned plot. And then we have a long series of data. And so now we want to join these together because we have 3 of these. I'll comment out the view function so you can use it if you want. Use view to look at data like you would in Excel. So what we want to do is essentially stack NDMI next to the NDSI next to the NDWI. So let's see if we can figure that out. So whenever I sort of don't remember exactly how a function goes, I usually go to the internet. And I know right now I want to do a join. So I'll say join in our tidyverse because I want to use the tidyverse index. And here I'm going to the tidyverse help page. And then I get to this page where it says inner join, left join, right join, full join. And this is where we're getting to sort of another goal of today's lesson, which is to remember how to ask for help inside of R. Okay, so now I have these function names. Thanks, Internet. And I can use a question mark, and then I can do question mark inner join. And what question mark inner join is going to do is going to pop up the help file for that function. And you can see you have this function here called inner join. Then you have an X, so it takes a data set on that one that's called X, and it takes another one called Y. Then you enter in the by column. So how do you want to join this data? In our case, we're going to be joining it by date time. So we want these things to stack together by the date. And it's going to also document what the different joins mean. So inner means only join if basically you have every individual matching. Left join means keep every single X observation, but drop any Y's that aren't matched by X. Right join is the opposite, so keep every Y observation, but drop any X that's not matched in Y. Full join is keep all of them, and you can sort of read more about these by going through the help file. And often up here, it's a little unclear exactly what you are doing, or what the function is actually doing. So I encourage you also to go all the way down and read the actual examples. So here they're doing actual joins. So they're joining band members to band instruments. Here they're joining band members to band instruments on an inner join, and they're only doing it by name. So what we're going to do is we're going to try to start joining our data sets. So we'll have NDMI and DVI, and we'll do inner join NDMI and DVI, and the by here will be date time. That didn't work. I think date time has a capital T. Yep. So that didn't work because I identified the wrong column because I didn't capitalize it. Okay, so that works. So now we can do we could do NDMI, NDVI, NDSI this way, where we do an inner join of NDSI on NDMI and DVI, and by equals date time. And now that should give us a full column, and you can see sort of how that works. And because this is the same satellite imagery generating all of these, we should have a full join like we have here. So we're not losing any data, even though we're doing an inner join. So every single one of those date times has a matching date time in NDMI, NDSI, and NDVI. Snow, moisture, and vegetation. But I don't like the way this looks because we just did 2 inner joins, and we now know we can use pipes to make that a little bit cleaner. So we can just pipe this join forward, and now we're going to take this object that was already joined, and we're going to join it directly to NDSI, and we're going to do it by equals date time. Okay, so let's rename this NDMI, and let's just call it the full I'm just going to call it full, actually. It's easier. Okay, so now if we view full, let's take a look at it again. Now we have NDW, NDMI is the first columns, and then we have NDVI as the middle columns, and snow is the last one. So snow, vegetation, moisture. And it's always polygon 1 and then polygon 2. So now we can actually go back up in here into our pipe and start renaming some of those. So let's go ahead and say, as we did, we can refer to this one and check out how we renamed it. So we just use the column index. So we're going to say burned NDMI equals 2, unburned NDMI equals 3, burned NDVI equals 4, unburned NDMI equals 5, burned NDSI equals 6, unburned NDSI equals 7. So now we've renamed all these with shorter, easier names to read, and let's double check that that makes sense. So we have NDMI, blah, 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 burned NDVI, unburned, oh, that's good that I checked. This should be NDVI. And then after that, I think it should work. Burned, unburned, burned, unburned, burned. Okay, great. Okay, so now we have a bunch of data arranged in what we, if you remember, we called that the wide format because every sort of observation is next to another observation of a different type at a different site. So let's comment this, join all data sets together, and rename columns. Okay. So one thing you'll notice here is, or rather here, is that we still have quite a bit of NAs, and we don't really want any NAs in our data set because when we have data, we want to make sure it's comparable. So what we're going to go do is go back to our code and make sure we drop NAs. But rather than, as we did here, writing out burned NDMI, unburned over and over and over again, we're going to use a different function. And what we're going to do is say filter if. So what this is doing now is it's using a predicate, which is a way of saying it's going to check in the data for if the data meets a certain category. So I'm going to just go ahead and remind myself how filter if works by doing question mark filter if. And over here, I'm going to see that it takes a table. So I'm piping forward our table here so that we already have that. And then it takes a variable predicate. And so this is a way of saying what is the type of variable I want to filter on. And if we go down to the examples, let's see if there's a filter if. There's a filter all. Here's a filter if. So this is filtering the dataset MT cars, and it's saying if the rounded down, so the floor is a way to round down, is equals to itself, then it can't equal 0. So let's go ahead and try our own filter, and I think we're going to do something a little bit easier. We're just going to say anything that is numeric, it can't be an NA. So these are all numerics. Datetime is not a numeric, it's a datetime object. And basically this is all going to be numeric. And we know that we can look at our data again and do structure full. And this is going to be date is a datetime, and all the other ones are numeric. So what we can do is say is.numeric, and we want it to, so now it's going to only grab the columns that are numeric, so it's going to ignore datetime, which is what we want. And we want to say that all those variables, so all vars, and then the dot is saying all those variables, so it's holding the place of burned NDMI, unburned NDMI, burned NDVI, unburned NDVI, etc. And we're going to say that those are not an NA, so we're going to do is.NA dot, and then we're going to say exclamation point. And there's a real strong chance this won't work, but we'll figure it out if it doesn't. Okay, so that just filtered it, and you can see we went from 2,102 observations to 1,590. And so if we now look at full again, we should see that there's no NAs anymore. And indeed, that's the case. We've dropped all the NAs. And so this, you can tell, this is a much more compressed way of writing something like this. Over and over and over, all the way through all 6 variables. And so now we have what I would call a fairly clean data set. And what we want to do with that data set is maybe plot the variables against each other. So let's go ahead and see what the relationship between NDMI and NDVI is, for example. So let's go ahead and do ggplot full. And this is why we're going to keep it in a wide data set. And we'll do this just for the unburned. So this is sort of the default relationship. So we'll do unburned moisture. So how does moisture is on the x-axis? So unburned NDMI. How does that influence unburned NDVI? And maybe we want the color to be month. So maybe we go back up to full, and let's go ahead and do our mutate, where we do month equals month, date, time. Again, this is from the previous video. We'll go ahead and add year because we might use that later. And now we've added a couple columns. And so we'll color this by month, because maybe this relationship varies by month. And then we're going to do plus geom point. Okay, so you can see there's sort of like a seasonal pattern. So here we're getting the winter pattern. It looks very different from the summer pattern, which is absolutely what we would expect. And you're seeing a pretty strong correlation between unburned NDMI and unburned NDVI. And that is made more difficult to look at because of winter months. So what we could do if we wanted to sort of clean that up is take the data set out of the ggplot call, replace that with a dot, and then now we're going to use the pipe functionality to do the same thing, but we're going to filter out the winter months. So we'll say month, and here we'll do percent and percent. So we don't want to keep any months that are wintry, so we'll say 11, 12, 1, January, February, March, and April. And here, I'm keeping all of those, but I actually want to drop them all, so I'm going to just go ahead and put an exclamation point, and then I want to pipe that forward and plot that. Okay, and then it looks like we're capturing some snowy day here in April, so maybe I actually want to go ahead and say I'm going to drop April too. And Colorado's weird, so there's still some snow, but basically we can see that there's definitely a relationship over here where if you have higher moisture, you have higher greenness, which makes a lot of sense. If you have more rain or more snow and a wetter soil, the vegetation is able to take advantage of that and grow more effectively. So that's useful. One thing that we can see here is there's just a few points out here. So maybe we want to change the limits of our x-axis. And so maybe we just add to our plot call, and we do xlim is, it looks like maybe it goes to -1, -0.1 rather. And then to maybe you want to see 0.25, and maybe we just want to take a look at it that way. And here we can really see this pattern a little bit more closely. In general, there's a cloud around here. Okay, so now we sort of looked at one way of looking at relationships in the variables, and we could also sort of do the same thing, but now maybe we do the burned. So let's do burned NDMI and burned. I can't spell burned and burned NDVI. Okay, so now my limit is removing far more rows of data. So I don't know if you see on this bottom left, it says remove 434 versus earlier only removed 20. So I'm going to take out these limits that I put in. Okay, and then now we see that we have two different regimes, which is exactly what I would expect given a burn. So basically, pre-burn, it looked a lot like the unburned areas, and post-burn, it has a completely different relationship. This is sort of indicative of a shift in the ecosystem. So let's go ahead and comment that. Great. Okay, but we were able to make that plot, and I think it looks kind of nice, and it tells us something about the data, but we were still working with the data never having been tidied, so we were still always in this sort of wide framework up here, and you can already sort of tell gathering this data set is going to be slightly harder than gathering prior, because now we have multiple columns that we want to gather over. So let's see if we can sort of get the data together in a different way. There's a lot of different ways to do this. This is why I'm pausing. So we have these labels up here called NDMI, NDSI, NDVI. And here I sort of renamed them already. But another way to think about doing this is we can force the data rather than joining it in a wide setup, which reminds me I should call this full wide. We can actually join it directly as a long data set, but we're going to have to do some renaming up at the top in order to be able to do this. So here, rather than just reading in the data, we're going to go ahead and rename it. And we'll do burned equals to unburned, burned equals 3. And we can just copy that and do it 2 more times, because these data sets are organized the same way. It's the same polygons. And so now we've renamed them. It's confusing though, because we haven't said whether it's NDMI or NDSI. So now we need to do one more thing. We need to do a mutate and say, I forget what I said, site. Nope, not site. We're going to do data. And then that's just going to tell us that this is NDMI data. And on this side, I'm going to just be careful to keep everything lowercase. It's just a little bit easier. Mutate data equals NDSI. Mutate data equals NDVI. And later in the semester, we'll sort of go over how to avoid writing all these things over and over again. This is repetitive. As soon as you do something basically 3 times, you should try to write a function so you don't have to rewrite it. But we'll get there eventually. So we've just renamed some stuff, and so now we have a new column. So if we look at NDMI, we have a data type column. And we have that for all of them. And what that does is it sort of identifies what the data is. So here was our way of getting the data together by doing an inner join. Now that we did it this way, with that data column, it's going to keep the sort of, that data column actually sort of breaks this way of doing it. So what we can do down here is on each of one of these, we want to remove that column. So we're going to do a select, which is a way of selecting different columns, and we want to remove the data column. And so we remove the data column for NDMI, we remove the data column for NDVI, and then we remove it for the snow as well. And that way, when we do this, it's going to look the exact same as it did prior, except that something is wrong. And when something goes wrong like that, and you changed a lot of things, the first thing you can do is break your pipe and check. So this doesn't like this. I'm adding this precursor called dplyr select because I'm worried that it's not using the proper select, and indeed that was it. So what was happening there is there's multiple packages that have this function called select. So if I do $select, there's both a dplyr select, and then I think lubridate has a select, and so it wasn't using the proper one. which is unfortunate. But occasionally this happens. And so basically what this does is it verifies that I'm getting the select function from this package called dplyr. And so to clean this up, I'm just going to drop this down. And so now we have the proper data set. And let's see if we rerun the whole thing. Okay, now it all works. And indeed, let's check if full wide looks the same as it did earlier. Okay, cool, it does. All right, so now we have our wide and clean data set, and we have the ability to make our long clean data set. And so I'm going to call this full long, and the way I'm going to do that is I'm going to bind together. So now I have 3 distinct data sets. They all have been read in and joined sort of horizontally, and now I want to join them vertically. And the way I'm going to do that is they all share the same names. So if I do names, that just returns the column names of the data. So if I do names NDMI or names NDVI, they're the exact same. So it's date, time, burned, unburned, and then the data type. And so what that allows us to do is it allows us to directly stack data on top of each other. And once we do that, it'll be in the tidy framework, or halfway to the tidy framework. So we're going to do rbind, NDVI, NDMI, and NDSI. And now if we look at that with view, we can see that we have all the data. And on this data set, we haven't filtered out the NAs yet, so we'll have to do that. And you can also see that it sort of is organized, so it just follows whatever I stacked first. So NDVI was the first one, so that's what you see first. And then if we just zoom way to the bottom, you get NDSI is the last one. So NDMI is somewhere in the middle of there. There we go. Okay, so let's go ahead and delete that. Stack as a tidy data set. However, this is not fully tidied yet, right? Because we still have this burned and unburned columns, and really those should be another thing that's split between site and site, and then there's a label for it, whether it's the sort of value, whether it's NDMI or NDVI. So let's go ahead and make that plot, and we'll make that data set. So we're going to use gather again. So we'll do we'll go ahead and pipe this forward, and we'll do gather. And I sort of want to make sure I get the right functionality for gather. So I'm going to go ahead and do question mark gather. Okay, so it takes data, and then I need to label the key. So the key here is actually we're just going to call treatment. So was it burned or unburned? It's not a real treatment, but let's call it site, actually, like we did last time, to keep ourselves from being confused. Key equals site, the same as last time. And then value here, we're actually just going to call value, because it could either be NDVI, NDMI, or NDSI. That's the way this data set is now organized. And we want to make sure we keep the date time column separate. And we also want to make sure we keep the data column separate. So it's sort of the data type. And so now when we do that, we'll get a data set that stacks. Now we have date time. What is the data type we're working with, NDVI or NDMI or NDSI? Then we have the site, and then we have the value. So the value here is now you have to look at the column to figure out if it's an NDVI value or an NDMI value or whatever. Okay, great. Now though, we still see that we have the same problem as before, where we have NAs. But with this data in a tidy data framework, it's a lot easier to filter it. So we're going to filter. We're going to say we don't want any NAs, and we just don't want any NAs in the value column. And so when we do that, we get a full long that's 10,000 variables, 10,000 observations. And so it cuts out a bunch of those NAs. And indeed, let's go ahead and look again at full. And now we have no NAs anywhere in the data set. And that's across NDVI, NDMI, NDSI, all of those things. Okay. So now we have a stacked and tidy data set, which is great. And maybe what we want to do here is just sort of look at the full time series for each one of these based on whether it was burned or unburned, and its the 3 different metrics we have. So NDVI, NDMI, or NDSI. So let's go ahead and make a plot of that. On the x-axis, we want date time. On the y, we want value. The color we want is to be site, so this is the burned or unburned. And then we want that to maybe be a geom line, because we're going to be trying to trace this across the graph. And then we want to do a facet wrap as a function of the data type, so as a function of data. And so when we plot this, we'll get these NDMI, NDSI, and NDVI plots. And if we look at these plots and try to interpret them ecologically, what we see is NDMI has a clear fire effect. So at post-fire, you had a much bigger decrease in moisture, probably because of a lack of shading, because you'd lost all your trees. And trees themselves sort of hold moisture in the tree. And then here we have the snow index, and what you can see when you plot the snow index is that they essentially look the same, which makes a lot of sense to me. These sites are right next to each other, so they're going to get the same climate. So this is sort of saying the climate forcing on this landscape is not different. The only difference is whether it burned or not. And then NDVI plots are similar to what we've already seen. Basically, you do have a clear fire effect. Even in the unburned area, there's an effect from that year, maybe because of a drought. But the unburned plot recovers back to sort of reference conditions, while the burned plot never really does. Okay, so this is sort of just some more advanced data management in R, and in class we're going to sort of continue to add to this, and we're going to actually look at are there correlations between NDMI and NDVI, and does the snow from the previous year affect the NDVI of the following summer? So look forward to seeing you in class.